Okay, hi, Assalamualaikum. My name is Azimah Sulaiman. So our group title is LED display. So this is our teammates, which is Lidyia, Ornrakwee, Nadia, and also Nadzirah. So we will start our presentation.
As introductions, our group chose the LED display test assembly code for assignment 3. On the EMU X0X6 emulator, we use code examples to find and run the actual code for the LED display test. Then, we have modified it and displayed the result as group work. The emulator was created with an X0X6 assembly built-in, and it can run programs on both PC and laptops. Typically, an emulator allows the host system to run software and use the peripheral devices designed for the guest system. Emulators, whilst also simple to use and inexpensive, have significant hardware and software limitations. We ran the real assembly code from the code examples through the simulator to obtain the original output. Then we added and changed some assembly code to obtain the modified output. First, we renamed LED to LED ISP, which stands for LED display. Following that, we ensure that all of the numbers are valid in both positive and negative integers. We already did this in assembly code because in the actual display test assembly code, the number 1 to 4 are positive and the number 5 to 8 are negative. Then we added the AND assembly code delay instruction.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nadzirah Binti Mokhtar and my metric number 282051. Today I will be presenting about the assembly code. It has two, which is the actual assembly code and the modified code. For my part, I will be presenting the actual code or original code. For this assignment 3, our group has chosen the LED display test, and here is the actual code for LED display test. Firstly, I will show you the actual code as stated in the screen, which is the start LED display, make pin, name LED, move AX 1234, out 199, AX, MOV AX, negative 5678, out 199, AX, external loop to right, values to port, MOV AX 0, X1, out 199, AX, include AX, jump AX HLT.
Hi, my name is Ornrakwee Suvanptum and my metric number is 280806. So I will present the original code in the emulator. So first of all, we open the emulator and click the code example, and we choose the LED display test. So it will display the code of the system. So as we can see, the name of the system is LED. So we have move AX 1234 out 199 and negative 5678 out 199. So here we can see the external loop to write the value to port. So we have move AX0 1 out 199, include AX, and jump 1. So that's all from me. I will pass to the next presenter. Thank you.
Then click the emulate button. So basically here, as you can see, we run the real assembly code from the code example through the EMU 8086 simulator to obtain the original output. The program ran by clicking or single step to manually execute a line of code and finally go back to the previous line. So as shown here, the result of original code and the looping number.
So this is our code after modify the code assembly for LED display. So we name it as a LED display, and here we use the number 1, 2, 3, 4, 5, 6, 7, 8, and also 9999. And at line 20, we use negative 1, 2, 3, 4, negative 5, 6, 7, 8, and negative 9999. Okay, we also add delay command for this assembly language that we already modified, which is call delay in line 8, 13, 18, 23, 28, and 33. Okay, in line 37, here the execution looping for number move 0x3 out of 199, and we also input call delay. After that, the looping will back to x3. And lastly, in line 43 is the command to delay the appearance of number. So here the delay is move C1 of O0 at FH is the speed for the delay, and we are using 8 as a speed. So that's all from me. Next is the output for this modified.
Assalamualaikum. My name is Lidyia Natasha Binti Fauzi. My matric number is 269423. Today, I will continue present about the modified result. For starter, we have modified the original assembly code for LED display test. For our project, we name it as LED dips. We modify assembly code by add number 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 9, 9, negative 1, 2, 3, 4, negative 5, 6, 7, 8, negative 9, 9, 9, 9. For all the number that we have modified, we have add a delay command. Moving on to the next, here is the execute looping for the number loops 0, x3 out 199. We also put call delay in this execution, and the looping will jump into the x3. Next, this is the command for the delay. The appearance of the number consists of delay is MOV CI, and 08FH is the speed for the delay. Next, MOVCH 008H. For more detail, I will show the result by run this assembly code. First, click the emulate, then run. So, as you can see, this is a looping number will pop up. So let's we change the speed by enter the number 2. Let's we change the speed by enter the number 2. Then press the run button. The result will show that the delay of the number is faster, like this. So we can conclude that speed for the delay 02 FH is faster than 08 FH. For more instance, let's we change 02 FH into 05 FH. Then click the run button. The result will pop out. As we can see that the result will show the delay of the number is more slower than 02 FH but more faster than 08 FH. The result is like this.
In summary, we can see that the emulator is a simple software to run LED display assembly code. We can easily add, edit, delete and modify the assembly codes from the actual code to generate an output using the emulator software. The emulator software also runs programs in step-by-step mode, just like a real microprocessor, and displays registers, memories, stacks, variables and flags. Furthermore, the emulative programs is extremely useful for those who are just starting to learn assembly code. It compiles the source code and runs it on the emulator in stages.